Hi guys, and welcome to a brief tutorial over 3.8 solving quadratics by graphing. So first question, what does it mean to actually solve a quadratic? Well, first let's address the question, what are solutions? Solutions can also be called three other names. Those names include x-intercept, root, and zero. By understanding that definition of what a solution really is in relationship to a quadratic, we can answer the question, what does it mean to solve a quadratic? It means find the x-intercepts. Now, where can you find the solutions on the graph? Well, where can you find the x-intercepts? On the x-axis. Now, what are the four parts of a quadratic equation? They are vertex, axis of symmetry, x-intercept, and y-intercept. With that taken care of, let's take a look at some different representations of a quadratic function. So if we take a look at our next page, the first thing we're going to evaluate is the idea of the function x squared minus 11x plus 30. And it wants to know, what would the solutions look like? Well guys, actually this one can't be solved. And the reason it can't be solved is because it's not an equation. The reason I know it's not an equation is because there is no equal sign. So, since this is not an equation, it cannot be solved. Now, you could simplify it, you could factor it, you could rearrange it in some way, shape, or form, but you'll never be able to solve it because there is no equal sign. The next format I'd like to take a look at is y is equal to x squared minus 11x plus 30. This actually isn't in a format that would be ideal for solving because there are two variables. You could solve for a specific variable, but you could never actually come up with a numerical solution. Typically, this format is used to graph it, or for graphing. Now, when a quadratic function is set equal to 0, this is the format used to solve. This is basically saying y is equal to 0, which on a graph is when x-intercepts occur. So when the equation is set equal to 0, you solve by finding x-intercepts. So guys, this is the format that we're going to be using today, where our quadratic equations are set equal to 0. The other option you're going to have for formatting is f of x is equal to x squared minus 11x plus 30. This is referred to as function notation. So when you're given function notation, you're typically given an x and asked to find y. So since the solutions that we're trying to look for today are x-intercepts, this formatting doesn't really work for us because in our case we're trying to find x, and in function notation format they would be giving us x. So again, another reason why our third option here is going to be the option we're looking at today. Okay, so let's graph a few examples. So the first one we're going to take a look at is 0 is equal to x minus 2 squared minus 4. So there's two questions we need to start out asking ourselves. First, is it equal to 0? The answer is yes. The second is, what format is it in? This one is in vertex form. So because it is in vertex form, I can go ahead and identify the vertex as 2, negative 4. That provides me with a starting point on my graph. Now, if I use the pattern of quadratics, which is 1, 1, 2, 4, 3, 9, I can graph the additional points on the grid. Since my A is 1, I'm not going to change the pattern in any way. So from the vertex, I can go 1, 1 and make a new point, 2, 4, make a new point, and 3, 9 to make an additional point. Because parabolas are symmetrical, I can mirror those points across the axis of symmetry to create the full parabola. From this graph, I can then identify the x-intercepts as 0, 0, and 4, 0, which means the two solutions are 0 and 4. Our second example is 0 is equal to negative 10x plus 16. So our first question, is it set equal to 0? The answer is yes. The second is, what format is it in? Well, this one is in standard form. Now, in standard form, to find the vertex, you could calculate the axis of symmetry, then take the axis of symmetry, plug it back into the original equation, and find the y value of the vertex. Personally, I find that a little tedious. I find the fastest way to get it to get the vertex is to convert it to vertex form by completing the squares. So that's what we're going to do here. In order to do completing the square, we'd start by grouping the first two terms together. From here, we would take half of b and square it. So since we're adding 25 to the parentheses, we would subtract 25 at the end. When we factor and simplify, we end up with 0 is equal to x minus 5 squared minus 9. So from there, I can identify the vertex as 5, negative 9. Since my a value is 1, my quadratic will stay the same. Quadratic pattern will stay the same, 1, 1, 2, 4, and 3, 9. I can mirror those points over the axis of symmetry and graph my parabola. So from this graph, and I can identify my x-intercepts as 2, 0 and 8, 0, meaning my solutions are 2 and 8. Our third example says 9 is equal to x squared plus 2x plus 1. We ask ourselves our first question, is it set equal to 0? Since the answer is no, before we can do anything, we must rearrange the equation. We're going to do that by subtracting 9 from both sides. That's going to give us 0 is equal to x squared plus 2x minus 8. Now that we have it set equal to 0, we're going to talk about the form. This one is in standard form. So again, not what I would consider the ideal graphing format. You could find axis of symmetry, plug that in back to the original equation, and find your y value of the vertex. But again, I think the most efficient method is by completing the square. So we're going to start by grouping the first two terms. And we have x squared plus 2x plus our blank minus 8. Take half of 2 and square it, and then we're going to subtract 1 at the end. When we simplify and factor, we get 0 is equal to x plus 1 squared minus 9, meaning our vertex is going to be negative 1, negative 9. So from here we go 1, 1, 2, 4, 3, 9, and mirror over the other side to get the full parabola. This helps us identify our x-intercepts as negative 4, 0 and 2, 0, which means our solutions are negative 4 and 2. For example number 4, we're taking a look at x minus 2 squared is equal to 16. First question, is it set equal to 0? Since the answer is no, we're going to subtract 16 from both sides, and we're going to be left with x minus 2 squared minus 16 is equal to 0. Now that it is in the correct format, I can graph. It's already in vertex form, so no converting is needed. and my vertex is going to be 2, negative 16. With an a value of 1, I can follow my pattern, 1, 1, 2, 4, 3, 9, and then 4, 16. So when mirrored over and graphed, this is what our parabola looks like. So from here we can identify the x-intercepts as negative 2, 0 and 6, 0. So solutions are negative 2, 6. I hope you found this lesson helpful. Please go see your teacher in tutorials if you have any additional questions. Thanks.